Okay, I'm going to highlight what I think are the two most common errors in A-level maths. The first one is questions of this type. Suppose you've got cosine 3 theta equals a half, and the solutions are between, say, 0 degrees and 180 degrees. Now I'm going to do the question wrong. So we get, this is the wrong answer, but it's very common. You get 3 theta. The first step is okay, is arc cosine of a half, which is equal to 60 degrees. But now I'm going to go wrong. I'm going to go theta equals 20 degrees. Then I'm going to find this is 20 degrees. Next solution, which is going to be this is minus 20. This is correct. This is the correct way to find the second solution. It's going to be 340 degrees. And then we add 360 to each of these, so it'll be 380. And add 360 to 340 is 700. I don't think I need to go any further. Oh, of course I don't, because we've found the answers. Well, we sort of found the answers, but this is wrong because I divided by 3 before I found all the solutions. So this is the wrong answer. Let me now do it correctly. What I should have said is 3 theta equals 60. And then I should have said, do the same thing as I did before. This is 60 degrees. So this is minus 60. So the second solution will be 300. Then add 360 to that is 420. Add 360 to that is 660. Now I divide by 3. So you get 20 degrees, 100 degrees. And that divided by 3 is 140. And that divided by 3 is 220, so it's too large. So those are my solutions. This is the correct way to do it. So basically the error is in finding the first solution and then dividing that by 3 and then finding the other solutions after that. It simply is wrong. You find all the solutions first and then you divide by 3. That's the first common mistake. The second common mistake is this one. It's to do with the binomial formula. Suppose you've got to multiply this out. I'll make the power low. I don't want to get too many terms. So you've got 2x to the 3. Well, this, of course, is 2x cubed plus 3 times 2x squared plus 3 times... Sorry, I made a mistake. 2x squared times 3y plus 3 times 2x times 3y squared plus 3y cubed. Now, the error this time, again, I'm going to do the question wrong. The error in this case is that people don't apply the power to the number, so they write this down. So you can see that I'm omitting. That will do. See, I'm omitting this. This, of course, should be 8x cubed, and this should be 4x squared. The correct answer. Let me put the correct answer down there. The correct answer should be 8x cubed plus 3 times 4x squared times 3y plus 3 times 2x times 9y squared plus 27y cubed. That's what it should be. Okay, those are the two most common mistakes in my experience that students make with A-level maths. There is one further thing actually. I must admit I've not actually seen this on a past paper, but I want to show this error, potential error as well. Suppose you've got to find the derivative of 1 over 4x to the half. Well, again, let me do it correctly this time. First of all, the correct answer, or the correct thing to do, is to, that's rather hard to differentiate as it stands. So I'm going to write the x, 1 over x to the half, I'm going to write it as x to the minus a half, and it's divided by 4, and then you differentiate that. Now, the error in this case is this. Student can see that you want to bring the root x to the top, but they bring the 4 up as well. So they write this. This, of course, is incorrect. And you can always tell when someone has made this mistake. You can always tell when someone's made this mistake because their answer is, in this case, it would be 16 times too large, because they've changed a quarter into a 4, so it's 16 times too big. Now, the same thing applies with integration, exactly the same principle. You can have a question like this: 1 over, say, 7x to the power of, say, 3. And it's the same thing. The correct thing to do is to write it like that, x to the minus 3 over 7, and you integrate that. And that's the correct thing to do. But the mistake is they write that as 7x to the minus 3. And again, as I say, you can tell when someone's made this mistake because their answer will be, this time, 49 times too large. Okay, fine, thank you.